Dear student, I am Dr. Harold Thomas, Professor in Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya Sagar. Today, I will deliver my lecture on different type of metamorphic reaction. In this lecture, I will proceed under the following heads: introduction, invariant reactions, divariant reaction, net transfer reaction, exchange reaction, discontinuous reaction, and finally summary. Hope it will be useful for you. Try to be regular in course. Metamorphism occur over a wide range of temperature, over 150 degrees centigrade to 1000 degrees centigrade, and pressure 100 bars to 10 kilobars or more. During this PT range, a large number of chemical reactions take place. Metamorphic reactions are very important to understand the different texture and new set of mineral which are stable under the new condition of pressure and temperature. Changing of temperature and pressure result into redistribution of elements in the new minerals. Normally, prograde metamorphic reactions involve dehydration or decarbonation. The large increase of entropy that involve the liberation of volatile phase from a mineral consensus that rising metamorphic temperatures will favor reaction that produce a separate vapor phase. The reaction among solid and fluid phases can be classified in various types based on what the reaction does, how the reaction progresses, or on the basis of different phases involved. The stability field of individual minerals or mineral assemblages are represented on a two-dimensional pressure temperature phase diagrams. The boundary lie between two stability field show PT conditions for an equilibrium state between phases in the two field. If change of pressure and temperature, the equilibrium state will be shift. A metamorphic reaction is an expression of how the minerals got to their final state, but a reaction does not necessarily tell us the path that was actually taken to arrive at this stage. Sometimes it is possible to deduce the path by means of a reaction mechanism. Thus, we will also explore reaction mechanism. If we are considered a rock of fixed chemical composition, then a metamorphic reaction state the principle of equilibrium. In other words, if we can write a reaction expressing equilibrium between the minerals we see in the rock, we expect that the reaction must have been taken place during metamorphism. We will first look at various types of metamorphic reaction. Let's consider a rock having fixed chemical composition. Then a metamorphic reaction states the principle of equilibrium, that is, equilibrium between the minerals. The various types of metamorphic reactions are as follows: solid-solid reactions, fluid liberation reaction, dehydration or decarbonation, oxidation reduction reaction. Solid-solid reaction, these are variety of metamorphic reaction comes under the category of solid-solid reaction. These are as follows: polymorphic reactions, exchange reaction, continuous reaction, terminal reaction, net transfer reaction, X-solution solvous reaction, discontinuous reaction, tie-line or non-terminal reaction, volatile conserving reaction. Polymorphic reaction. Polymorphic reactions are a special type of solid-solid reaction that involves phases of identical composition. Classic examples are the reaction among the aluminum silicate, kyanite, sillimanite, andalusite. See the phase diagram. The conversion of graphite to diamond at high pressure, calcium carbonate, calcite to aragonite, equilibria, and quartz phase. The solid-solid reaction plot on a PT diagrams as essentially straight lines. This is because the delta S and delta V of reaction does not change much with varying pressure or temperature, to the extent that delta S and delta V do not change with P and T. They change about the same amount for both the reaction and the products. In the Al2SiO5 system, the stability of aluminosilicate minerals has been investigated by Holdway in 1971, is the most accepted and preferred by the petrologists. See figure. Each of these Al silicate define a stability field in PT space. Rock of peltic composition recrystallize in regional metamorphism from kyanite at pressure more than 4 kilobar. Andalusite is usually found in contact metamorphism, while sillimanite is formed at high pressure temperature in rock of suitable composition. On the basis of that, one can define metamorphic zones. The triple point of aluminosilicate located at 501 degree centigrade and 3.76 kilobar pressure in PT diagram. But these could be a problem of metastability. In the CaCO3 calcite aragonite transition has been investigated, which shows that in carbonate rocks, high pressure aragonite is stable. Usually during blue schist phases, this transition takes place in the solid state at moderate temperature and high pressure. Mostly metamorphic rocks contain quartz, while high temperature phase tridymite occur in sanidinite phases along with quartz. Almost all carbon in metamorphic rocks occur as low pressure polymorphs graphite. In some rock of eclogite phases, diamond is found. It is doubtful whether any surface rock could achieve diamond by burial by the reaction graphite change into diamond. Second, exchange reaction or continuous reaction. Exchange reaction involves chemical components being exchanged between phases, so compositional change, but modes remain the same. No phases disappear and no new phases are produced. The exchange reaction is common in solid solution silicate minerals involving substitution of Fe+2 and Mg, the element which have a similar ionic radii and identical charge. Exchange reactions are continuous reaction. An example is anite plus pyrope give rise to phlogopite plus elmandine. The two minerals biotite and garnet effectively exchange Fe+2 and Mg when they are in domain equilibrium. Exchange equilibria like this are only slightly affected by pressure because the volume change is negligible. Delta V reaction equal to 0 and used as a good geobarometer or geothermometer. The exchange reaction between garnet biotite is in fact the result of two invariant reaction for each end members. Anite plus sillimanite plus quartz give rise to elmandine plus potash feldspar plus water. Phlogopite plus sillimanite plus quartz give rise to pyrope plus potash feldspar plus water. The reaction 2 take place at low temperature while reaction 3 take place at high temperature. Subtracting reaction 3 from reaction 2 give the exchange reaction 1. Anite plus pyrope give rise to phlogopite plus almandine. Such exchange reactions involve two solid solution phases are also called sliding reactions. The others exchange reactions are garnet corderite, garnet orthopyroxene, garnet clinopyroxene, and orthopyroxene, clinopyroxene, etc. Continuous reaction involves phases that may vary in composition. Such reactions are more common than discontinuous reaction because compositional variation of either fluid or solid phases is typical for geological material. Continuous reaction occur over a range of conditions so that products and reactant coexist stably over a range of conditions, but the composition of the phase changes systematically as condition change. Continuous reaction may be exchange reaction. Solid-solid net transfer reaction, often just called solid-solid reaction, occur among solid phases of differing composition. These phases may include elements found in fluids, hydrogen, chlorine, but those elements are conserved in the solid phases so that no fluid phase H2O, CO2 are involved as reactant or products. Solid-solid net transfer reaction can be continuous or discontinuous, and they may be terminal or tie-line flip reaction. 3-anorthite give rise to sillimanite plus gracilorite plus quartz. That makes the upper stability of anorthite is a very useful reaction whose stability is much lower than that of albite. In terminal reaction, the reactant phase is completely consumed and changed to product phases. Both delta S and delta V are high. Other terminal or net transfer reactions are Fe corderite give rise to almandine plus sillimanite plus quartz. Gracilorite plus quartz give rise to anorthite plus wollastonite. Terminal reactions involve the creation of a new phase from 2 or 3 other phases, or in the other direction, the decomposition of one phase into 2 or 3 others. They may be solid-solid reactions or they may be involved a fluid phase. An example of a terminal reaction is chloritoid give rise to sterolite plus garnet plus chlorite. Discontinuous reactions are those that occur at a particular temperature for a particular pressure. For these, a curve or line can be drawn on a pressure temperature PT diagram. Kyanite give rise to sillimanite reaction. On the other side of the curve, a different set of phases is stable. In a discontinuous reaction, products and reactants can only coexist stably precisely at the equilibrium reaction condition on the reaction line in PT space. Discontinuous reactions are always net transfer reaction. In these reactions, the component of reactant minerals migrate to minerals of the product phases, thereby forming new minerals association. The terminal reaction occur between pure phases and without any involvement of fluid phases. These are univariant reaction and are of terminal nature. The jadeite is formed by two reactions. Albite give rise to jadeite plus silica, albite give rise to jadeite plus quartz, and albite give rise to naphthalene plus jadeite. X solution or solvous reaction. X solution or solvous reaction occur in phases exhibiting complete solid solution at high temperature but limited solid solution at low pressure below the critical temperature where a solvus is defined. As the phases cools, it exalts another phase, usually along cleavage planes, etc. Because both the exsolving and exsolved phases are solid. Exsolution reactions are considered solid-solid reaction. Alkali feldspar provides important solid-solid reactions. Mixing processes in some rocks of low temperature metamorphism, albite and potash feldspar may coexist as a separate phases. During gamma-rate phases, temperature is sufficiently high so that almost total mixing between the two alkali feldspar occurs. The Solvus reaction is an order or disorder reaction and sensitive to temperature but affected by pressure. Discontinuous reaction, tie line or non-terminal reaction. The discontinuous FeMg reaction are univariant reaction, P equal to C plus 1 or tie line switching non-terminal reaction. These reaction also known as net transfer reaction. For example, the Al2 SiO5 system with excess SiO2 and H2O in low grade of metamorphism, the reaction Al2 Si4O10 pyrophyllite give rise to kyanite plus andalusite plus quartz plus fluid. Define a reaction boundary on a PT diagram. This boundary can be determined experimentally or can be calculated using thermodynamics properties of the phases involved. Discontinuous reactions are those that occur at a particular temperature for a particular pressure. Further these, a curve or line can be drawn on the pressure temperature PT diagram. Kyanite give rise to sillimanite or either side of the curve. A different set of phases is stable. In a discontinuous reaction, products and reactants can only coexist stably precisely at the equilibrium reactions condition on the reaction line in PT space. Discontinuous reaction are always net transfer reaction. Dear student, today in this lecture we have discussed about the different type of metamorphic reaction. I have covered this topic under the following heads: introduction, invariant reactions, divariant reaction, exchange reaction, net transfer reaction, discontinuous reaction. I believe this lecture was useful for you. For further studies, please read the textbooks, references and links given in the text.